surroundings, I'll teach you about the interconversion of the three states of matter. The states of matter are interconvertible. That means the state of matter can be changed by changing the temperature or pressure. By increasing the temperature, solid can be converted to liquid state, and on further heating it can be transformed to gaseous state. And on decreasing the temperature, that means on cooling, gas is converted to liquid state, and liquid on further cooling converts to solid state matter. For example, when ice is heated, it is transformed to liquid, and the process is called fusion. Similarly, when liquid is heated, it transforms to gas, and the process is called vaporization. When gas is cooled down, it is converted to liquid state of matter, and the process is called condensation. When the liquid is further cooled down, it can be converted to solid state of that same matter, and the process is called solidification. There are few materials which on heating directly goes to gaseous state from solid state, and on cooling directly goes to solid state from gaseous state. This process is called sublimation. For example, camphor, ammonium chloride, which are at room temperature in solid state, but on increasing the temperature directly goes to the gaseous state without going to the liquid state. The temperature scales formula is given here. We know the temperature scales, the Celsius scales, Kelvin scales, Fahrenheit scales. The degree Celsius value of temperature is equal to the Kelvin value of temperature minus 273. That means the Kelvin value of temperature is equal to degree Celsius value of temperature plus 273. With this we understand that 0 degree Celsius is equal to 273 Kelvin. Celsius to Fahrenheit scale, degree Celsius is equal to degree Fahrenheit minus 32 into 5 by 9. Similarly, degree Fahrenheit, if you need to find, is equal to degree Celsius into 9 by 5 plus 32. So you can use these formulas to convert the temperature from Celsius scale to Fahrenheit scale. Next part is evaporation. The change of a liquid into vapor at any temperature below its boiling point is called evaporation. It is different from boiling. Boiling occurs at a particular temperature called the boiling point. Above that also, boiling may be possible, but evaporation is possible at all temperature. Evaporation is a surface phenomena. Particles from the surface gain enough energy to overcome the force of attraction and changes to vapor state. The factors that affect the rate of evaporation are the surface area, the temperature, humidity and wind speed. Increase in the surface area increases the rate of evaporation. Increase in the temperature increases the rate of evaporation. If humidity is increased, the rate of evaporation is decreased. High humidity in the rainy season does not allow our clothes to get dried very soon. Increase in wind speed increases the rate of evaporation. So we have seen that if the surface area is increased, then the rate of evaporation is increased. Like when you are wiping your blackboard, when it is required, or when mopping the floor, it gets dried very soon because the surface area is more. But if same amount of water that you used for mopping you're keeping in a glass, it will not be evaporated so soon. In a hot sunny day, the clothes will be dried faster because high temperature increases the rate of evaporation. See, in the surface, there are high energy particles, so it starts evaporating. Medium energy particles are pulled back into water and lower energy remains as liquid. Evaporation causes cooling, and this application is only used for the desert cooler. When a liquid evaporates, the particles of the liquid absorb heat from the surrounding and evaporates. So the surroundings become cold. For example, people sprinkle water on the roof or open ground because during evaporation, water absorbs the heat and makes the hot surface cool. During summer, we sweat more. And when this sweat gets evaporated, how does it evaporate? Sweat absorbs the heat from our body, making the body cool. Wearing cotton clothes in summer keeps us cool because cotton absorbs sweat, and when the sweat evaporates, it absorbs heat from our body, making the body cool. See, the diagram of desert cooler is given here. The two more states of matter are the plasma state. Example for plasma state are, we find this in sun, in the nebulas, in the auroras, neon lights, plasma TV you might have heard of and you have seen also, and the lightnings. The fifth state is Bose-Einstein condensate. Most recently discovered state of matter. It is formed when supercooled. When matter is supercooled to 0 Kelvin. That is also known as absolute zero temperature. 0 Kelvin is the temperature when molecules stop moving. So when the particles of matter are not moving, that means the kinetic energy has become almost zero. So the 5 states of matter now you shall be able to understand so well after this class are solid, liquid, gas, plasma state and Bose-Einstein condensate. Plasma is an ionized gas, a gas into which sufficient energy is provided to free electrons from atoms or molecules and to allow both the species, the ions and the electrons, to coexist. We see this in the sun, core of the stars, the auroras. The application is there in plasma TVs. And the Bose-Einstein condensate, it occurs at ultra low temperature, close to the point that the atoms are not moving at all.